Hey everyone, and welcome. Today, we're going to dive into something that's like the absolute backbone of pretty much every modern database, table relationships. It's the secret sauce that keeps everything neat and powerful, so let's get right into it. Okay, so just think about your everyday life for a second, right? Everything's connected. A person has a passport. A customer has a whole history of orders. So how in the world does a database, just a big collection of spreadsheets basically, how does it keep track of all these connections without just turning into a total chaotic mess?
Well, the answer is actually super simple and kind of elegant. It's all about relationships. See, instead of just shoving everything into one gigantic, messy file, databases are smart. They split up the data into smaller, logical tables. And then, and this is the magic part, they create connections or relationships between them. That is the core idea we're going to unpack today.
Okay, so here's what we've got on tap. First up, we're going to tackle the big why. Why do we even need to connect data in the first place? Then, we'll get into the nitty-gritty, one-to-one, one-to-many, and the super useful many-to-many relationships. After that, we'll see where you actually run into these in the real world, and we'll finish up with a little quiz to make sure it all stuck.
All right, let's start at the beginning. Before we even get into the how, we got to understand the why. I mean, what problem are we even trying to solve here? So just imagine for a second, an online store that keeps everything in one giant spreadsheet. This means every single time a customer buys something, you'd have to retype their name, their address, their phone number, all of it, over and over again. You can see the problems, right? You'd have tons of duplicate data, which is just super inefficient. And what happens if you accidentally misspell their name just once? Boom. Now your information is inconsistent. For a database, that is an absolute nightmare.
And this is where the genius solution comes in. Instead of repeating all that customer info, we just store it one time in a nice, clean customers table. Then, over in our orders table, we just point to that customer. We reference them using a unique ID. And the way we do this is with something called a foreign key. It's basically just a little pointer that links back to the customer's main ID, their primary key. It's this simple little trick that keeps all our data clean, organized, and totally reliable.
Okay, so we know why we need to link tables. Now let's get into the how. We're going to start with the simplest type of all, the one-to-one relationship. Just think of it like a perfect match. The rule here couldn't be simpler. For every single item in Table A, there can be exactly one, and only one, matching item in Table B. And it works the other way around too. It's a direct one-to-one pairing. And a perfect example of this is a person and their passport. You can only have one passport, right? And your passport belongs only to you. So look how we link them. We use the person ID. In the person table, person ID is the primary key. It's what makes Alex unique. Then we use that same ID over in the passport table. There, it's called a foreign key, and it just points right back to Alex. Simple as that. That's our one-to-one connection. All right, moving on to the absolute workhorse of the database world. Seriously, the one-to-many relationship is by far the one you're going to see the most out in the wild. So here's the deal. One record in our main table, let's call it the one side, can be linked to lots of records in another table, the many side. But, and this is key, each of those records on the many side can only point back to one single record on the one side. Let's look at an example and it'll all click into place. Okay, so we've got one customer, Maria. Her customer ID is 22. Now if you look over at the orders table, you can see that her ID, 22, shows up for two different orders. See that? So one customer, Maria, has many orders, but each of those orders, order 1001 and order 1002, they each belong to only one customer. That's your classic one-to-many relationship right there. Okay, let's tackle the last one. It's the most complex, but it's also incredibly powerful, the many-to-many relationship. This is how databases handle really complex connections, like students in all the classes they take, or, all the tags on a social media post. So let's set up the problem first. We've got a table for students and another one for courses. Now we need to link them. But if you think about it for a sec, this is a little different than the last couple of examples. Here's the big question. A student can sign up for a bunch of different courses, obviously, and at the same time, any one of those courses is going to have a bunch of different students in it. So you can't just put a course ID in the students table or a student ID in the courses table. It just doesn't work. So what do? Well, the solution is really, really clever. We actually create a third table. It's often called a bridge table or a junction table, and its entire purpose in life is to sit right in the middle and connect the other two.
And here you can see exactly how it works. See that enrollment table sitting there in the middle? Its only job is to link students to courses. It doesn't have names or anything like that. It just holds pairs of IDs, a student ID and a course ID. Each row in that table is just a single connection. This student is in this course. By making a bunch of these simple little links, we can build that super complex many-to-many relationship. And what's really cool is you can also store extra information about that specific link right there, like the grade that student got in that particular course.
Okay, so I know this might all seem a little bit theoretical, but I promise you, this stuff is the literal foundation of the digital world you use every single day. Let's just look at a few quick examples. Think about it. Every time you buy something online, that's a one-to-many relationship between you, the customer, and all your past orders. The course catalog at any school, that's a classic many-to-many relationship. Your bank connecting you to your different accounts, a company's CRM system linking customers to all their transactions, it's all built on these exact same ideas.
All right, so let's do a super quick summary. One-to-one, that's our perfect exclusive match, like a person and their passport. One-to-many, this is the most common one, where one thing can have many related things, like a customer and all their orders. And finally, many-to-many. This is for the complex stuff, like students and courses, and we solve it using that special bridge table.
Okay, you've seen the theory, you've seen the examples. Now it's time for a little pop quiz to see if you've got it down. Okay, first up, what's the relationship between a person and their passport? Take a second to think. If you said one-to-one, you are absolutely correct. Awesome. Okay, next one. A customer and all their orders. What do you think? Yep, that's our classic one-to-many. You're getting this.
And now for the big challenge question. How would you set up the tables for students and the courses they're enrolled in? Remember the trick. One student can take many courses, and one course has many students. So the answer isn't 2 tables, it's 3. You need your students table, your courses table, and that super important enrollment breach table right in the middle. If you got that, you've really mastered this.
And that really brings us to the big takeaway here. Understanding these relationships isn't just a nice-to-know thing. It is the key to building good, solid, real-world databases. Without them, data just becomes a messy, repetitive, and totally unmanageable nightmare. So now you know the secret sauce that keeps the digital world so organized.